So we're gonna wait 3 more minutes and then we'll jump right in. I'll put that in the chat as well. All right, Arun, we can get started. We gave people a few extra minutes to jump in. I think we added actually just one here in the last 30 seconds. So I think we're good to go.
All right, that's good. Hi, everyone. Thanks for joining today's workshop. So today's workshop is about Oracle Cloud Infrastructure and using Checkpoint Partner solution, which is like a CloudGuard solution. And the idea is like we're going to do a workshop. So we'll do a quick intro first, and then go to the outline, and we'll cover how the architecture will look like. And then we will have a hands-on experience on workshop part. Myself, Arun Punia, I'm a solution architect at Oracle Cloud Infrastructure. I work with Partner Solution, and Checkpoint is one of the partner to onboard those solutions on marketplace and validate their use cases.
Yeah, my name is Jeff Engel, Cloud Alliance Architect at Checkpoint. I kind of handle all things Oracle integrations at Checkpoint, including Oracle Cloud, and I'm based in the Americas.
Yeah, my name is Arnfinn Strand. I manage a team of cloud solution architects across EMEA in Checkpoint. So, of course, OCI is one of the solutions that we help our customers, partner, and internal teams with.
Thank you, Jeff. Thank you, Anna. So as I mentioned, like we're going to cover an outline, how the workshop will look like and what we're going to cover. So if you don't have access to the workshop link, let me share it quickly on the chat.
And while he's doing that, just to set the stage, this is definitely a hands-on kind of walkthrough. And then if you have the ability to run it yourself, that's even better, but you're more than welcome just to watch. But it is definitely not death by PowerPoint. We are going to be walking through step by step through an actual deployment and on Oracle and on the Checkpoint side.
Correct.
And feel free to please be chatty. Please feel free to throw messages in the Q&A so we can track them the best. Chat, if worst case chat, but Q&A is ideal for us. We can track it better. But we appreciate it. Thank you.
Thank you, Jeff. Yeah, so as Jeff mentioned, this is definitely a hands-on experience workshop. So the idea is that we just cover the outline first. So the outline, as you see in the left-hand side, you can deploy the resources which are required to from checkpoint point of view, as well as an OCI. You can deploy them manually as well as using Oracle Resource Manager. Then we're going to cover how you can deploy the firewall using Marketplace. Since we might use the Oracle Resource Manager, but I will show you how you can still use that. Then we will cover how you can configure the initial configuration as well as the required routing and all on the CloudGuard. And to support the traffic and validating the traffic, we will cover how you can use the Smart Console to manage your security manager, as well as from security manager, how you can push the policies and the required configuration to manage your cluster. So the idea is like we're going to use the CloudGuard product of Checkpoint, which is a security gateway, which is also available on OCI Marketplace. So we're going to cover high availability use case, like in active passive cluster. The only caveat is like to use this OCI Marketplace listing, you have to ensure that you use the paid tenancy, because OCI free tier currently doesn't expose the OCI Marketplace listing. So even though if you are new to an OCI and you register an OCI free tier, you can explore the networking parts and all, but you might not be able to use that checkpoint listing. So for this workshop, it's as Jeff already sent a prerequisite email, as well as like as you mentioned here, you need to have a paid tenancy. And this listing is available on Bring Your Own License as well as the paid listing. Bring Your Own License is available in US and non-US market across globe. And paid listing is currently exposed in US, but there is a plan to expose it outside of the US also.
And correct me if I'm wrong, Arun, but folks outside of the US can use the paid listings. They just have to pay in US dollars. Is that correct?
No, currently those listings are not exposed outside of
Got
US.
it. Okay.
So currently that's the outline will look like for the workshop point of view. And before we jump on the workshop, let me show like how the overall architecture will look like for this workshop. So as you see, we are using OCI infrastructure particular region. Within that region, you will have dedicated VCN like a virtual cloud network. So the idea like we're going to follow the hub and spoke model. Hub is there will be a dedicated hub VCN, and spoke VCN is dedicated application tier VCN, like a web tier or database tier. In this hub VCN will have our firewall. So firewall, there'll be cluster of firewall, like in high availability use case. So CloudGuard 1 and CloudGuard 2, they'll be communicating over HA using the backend subnet. And as you see, there are two subnet here, front end and backend. So each firewall will have an interface into that subnet. And we are using dynamic routing gateway, which is like virtual router to communicate between VCN as well as any traffic coming from on-prem, like as a virtual circuit or IPsec, it terminates it there. You can use the LPZ, but the recommendation is going with the DRZ to communicate between VCN, because it's supposed close to 300 VCN to communicate each other. And then we are using some service gateway. If you choose to go to the object storage without going over internet, you can go via service gateway also. At the same time, if you want to go to outside, then the front-end subnet has a route table entry pointing to the internet gateway, and that allows you to communicate outside. And this will also allow us from coming outside via the front-end subnet interface public IP and go to the spoke VM. So we'll cover all these east to west traffic between web tier and database via firewall, as well as north to south inbound and outbound traffic. So we'll cover those use cases and we'll show you like how you can validate those traffic and what are the required configuration on the CloudGuard. All right, so let's look at the workshop outline first quickly. So we already covered the outline part. So this is just a workshop, just tell you, I want to highlight this one more time, because you need to have access to the OCI Marketplace listing. And to have access to those listings, you need to have a paid account. And this is the same architecture which we are following. So like two CloudGuard deploying HA cluster, front-end, back-end, DRG, web tier, database tier, internet gateway, service gateway, and all. So how you can deploy this architecture, if you see here, so we're going to just go on to the next step, next lab environment. So this is like just a prerequisite. If you, just in case if you are new to an OCI, you can sign up for the free tier. But for this workshop, you would need a paid account. But if you are new to an OCI, you can always sign it up. It gives you like a $300 credit or month, depending on whichever comes first. So that credit allows you to get yourself familiar with an OCI console and all. But since this workshop is focused on a Checkpoint and the partner solution, you would need that a paid account to go from here. All right. So as I mentioned earlier, like how you can deploy this workshop architecture looks like. This architecture, how you can deploy this architecture in an automated fashion way, as well as the manual. So what we're going to do, we're going to follow the Oracle Resource Manager concept, which allows you to write a Terraform code, and using the Terraform stack file, you can deploy the resources. And at the same time, once we finish the deployment, we're going to use that, we're going to follow the manual step just to see how you can follow along and all the resources are created successfully. So the first step is like you go into the this lab 0, which has these are like OCI console listing and all. And before you consume this listing, if you are curious if you have access to this listing or not, you can go to an OCI console. Click over here. Search for all application or marketplace, whichever you prefer. And then it will take you to the marketplace. And from there, you can search whether you have access to that listing or not. So we are using this bring your own license model. The reason behind it because Checkpoint gives you a 30-day trial license, which allow you to expose as well as test it out the basic, do a quick POC or live environment and all. But you can always increase that license from 30 days to onwards by connecting with the partner directly if you're using bring your own license. But the paid listing, they are already have inbuilt license. Unfortunately, they are not available outside of the US market at the moment. So bring your own license, these are the two listings. One is the manager, Checkpoint Security Management Platform. And then another one is CloudGuard Security Gateway. So that's the bring your own license model. So we're going to use those two listings. So there's the prerequisite of Lab 0. So make sure you have paid account and you have access to those listings. All right. So the first task is like how you can deploy the using Oracle Resource Manager. So you can click here, and this clicking will download a zip file locally. But at the same time, this click is this Terraform code deploys like additional resources. When I say additional resources, like it has a 2-spoke VM in web tier, 2 database VM in web and database tier. The size of the CloudGuard is like VM standard 2.2, and CloudGuard security management is also 2.1. So just in case if you want to avoid this Terraform code to provision more resources, we have written a small Terraform another code, which I will share it on the chat. So this allows you to deploy minimum resources. When I say minimum resources, it's more of around like what is the minimum number of 1 VM into web tier, 1 VM in database tier, and size of CloudGuard is like 2.1, because in the end we need only 2 VNIC, right, for our workshop. We're not concerned about throughput at the time, but we need only 2.1 minimum shape, which we need. And you can always increase the size using the OCI console if you choose to. So this is an object bucket URL which allows you to expose into the Terraform code. And this is the workshop which we just following along. All right. So to do that, what I've done before the workshop, I just created 2 compartments which doesn't have any resources at the moment. So there's a demo 1 and demo 2. Demo 2 we'll use for minimum resources. So if you go into OCI console, click on compute instances. If you choose your compartment on the left hand side, you will see there is no resources here. So what we will do, we go into stack. Let's move to demo 2 first. So click on create stack here, click on zip file and browse the code which we just downloaded locally. One is for minimum resources, another one is for generic one. So minimum one is this one. Click on next. So you see it's deploying the 2.1 shape on the compute, which is like checkpoint CloudGuard, and the VM standard 2.2 is for manager, and VM standard E3.flex. So those are like different shapes available on OCI console. If you're curious, you can just scroll down from here or choose which you want to use, or you can just keep those values default for the workshop purpose. So choose your AD domain, because if you are not familiar with an AD, is just an availability domain, like logically separation of providing high availability like resilience. In a way, like each region usually have 3 ADs, but if a region is new and all, usually they have single AD, but within the single AD, they have like multiple fault domain. So you can choose those fault domain also if you choose to. Then we're going to keep the default value. Currently, the Terraform code is just like create new VCN and subnet. But if you want to modify it, you can modify to use the existing VCN and subnet, but that will require some modification on the Terraform code. But for this workshop, we are creating a new VCN and subnet environment. So you choose the keep everything is default value, like management subnet is the front end one, trust is the backend subnet. This is the web spoke and database spoke and all. And this is the dynamic group. So just to avoid if there was already a dynamic group, I'm just putting a different name for the dynamic group and policies. So dynamic group, the reason of using dynamic group is on CloudGuard HA cluster, we assign the floating IP on the primary firewall, and using the instance principal method of dynamic group, we use that dynamic group to move the floating IP from one primary firewall to the secondary firewall. And how we do that, like to support that, Checkpoint has written some custom plugin based on the OCI API, which is responsible for when the failover happens to move the floating IP from primary firewall to the secondary firewall. All right. So we're going to keep everything in default value, and just to make, you can see if you want, if you're curious, you can just double check those value. Click on create. Okay. So we click on the plan first, just to see everything is running as smoothly. In the meanwhile, let me open another tab. And then we'll go to the demo compartment and deploy that stack, which we just downloaded from this workshop directly. Click on demo. So as you see, it's currently 2.4. The shape is increased because I had the number of resources. That's the reason I'm keeping the default value. But if you want, you can choose it. You can modify it if you want to. So everything is by default the same, like in the firewall common configuration, we're just using the create new VCN subnet strategy. And this is for our security list on our subnet level. So this is like a front-end firewall cider, front-end subnet cider, backend subnet cider, and everything is, I'm keeping default value. All right. So let me put the name of demo. All right. So currently I'm just going to click on run apply directly because I know that plan will work for this stack. So, but for the production purpose, you should always check the plan first just to ensure everything is as expected. So if you go into our previous stack on the demo 2 compartment, so plan should have been successfully succeeded. So that's what we're going to do. We're going to just apply here. And behind the scene is to deploy all the minimum resources which we talked about. In parallel, like this is the Terraform stack on our demo compartment, which is using this directly link which was downloaded from here. So it's going to deploy that. So if you follow along this workshop, so what we did, like we went to developer services stack part. So we just click on create stack, uploaded the zip file, which we downloaded locally, then updated, make sure that compartments and Terraform version was right. And this compartment OSID and all, which was like the default value, which we just kept it like demo for our compartment and demo 2 for the minimum resources. We updated the public key, AD domain, and we chose the default value of create new VCN and subnet. And then we click on Terraform, create Terraform stack got created. Then we did the plan for the minimum resources. Then we just applied it. So once you apply it, ideally, like we should see the Terraform is successfully applied all the resources, and you would see a number of instances as well as the networking, all the subnets and are created successfully.
Yeah, and just to make sure everyone's clear. So essentially Arun is creating 2 independent environments, one with lesser resources and one with the full resources, so they can see both, and then also saves you money if you're doing it on a paid account that you don't want to spend a lot of money on.
Correct. So those are 2 independent resources,
Yep.
just to show.
So you
like
wouldn't have to do both of those, and as part of this, you can just pick one, right? One of either the lesser resource requirement or the full workshop resource requirement.
Exactly. You can just that's why we share the minimum resources zip file, like a
Exactly.
authentic
Yep.
request. You can follow. You can use the same zip file to deploy it. So what I wanted to show, like this is the stack. So apply, as you see, the minimum resources was successfully applied on the demo 2. So if I go into my demo 2 compartment or directly click on the instances, if you're curious, you can always search it here. But what I have done, like I just pinned some of the links here directly. So demo 2. Okay, so this is the demo 2, as I mentioned earlier, we're going to use the VM standard 2.1 for checkpoint CloudGuard firewall, as well as VM standard E3 flags for our spoke VM. Currently, there's only one VM in each spoke, and we are using the checkpoint security manager. So you can use those minimum resources to test out the workshop. At the same time, for this workshop, since we are following this workshop link, and there are some screenshot and all, so that's why I went ahead with the demo compartment, which has the more resources and all. So let me click it here. So as you see in our demo compartment, and the resources got applied successfully completed. You can see variables, what was the output variables, as well as any kind of additional output. You can see it from here, as well as if you go into our instances here, you would see they are CloudGuard 2 and CloudGuard 1 and the checkpoint manager, which is using the default shape VM standard 2.4. And there are 2 VMs in each spoke VM. Just to this is the reason of creating 2 VM, because I wanted to enhance a point, like if your VM is trying to communicate from web app 1 VM to web app 2 VM, they are in the same subnet or a different subnet, it might not go to the firewall. We will cover this, like the reason is because the whole saddle needs to be, if you want to inspect the particular subnet, you have to create a routing in a way that you expose the whole saddle of that VCN to the firewall. But we will cover it like once we go to the workshop part. And so currently, like once we did the apply command, we just saw that all the instances are created and all. But in the end, like I'm saying, like if you are already completed within the Oracle Resource Manager, you can skip the lab 1 and lab 2, which are the manual step, and lab 3 onwards. But we will cover the lab 1 and lab 2 just an overview, because we want to cover like the right resources are created successfully. All right. So this is like the first step of this lab 1, which is the task 1, which is creating configuring hub VCN. So we want to see like on the VCN level. So if you go into networking, select the virtual cloud network. So we select the virtual cloud network on the left-hand side, you choose the compartment. So in our case, is the demo compartment. So you would see that there are 3 VCN which we created using the Oracle Resource Manager. So this is the firewall VCN is the hub VCN. So the first step of the VCN is what we're saying, we create a new VCN. So if you're new to an OCI, you can go into Virtual Cloud Network and click on create VCN. This will allow you to enter the name and the CIDR which you want to enter, like anything unique, and the DNS label and all. And you can as the free from tag or the user defined tag, depending on what you want to do. How do you want to track it? So in this our case, we have already created a firewall VCN. So within the firewall VCN, we have two subnets, front end and back end subnet. So if you follow the workshop, the first step is creating hub VCN, which based on the particular side, and the name of the hub VCN is the firewall VCN. Entering the firewall VCN, the CIDR name, and it will come with the default security list as with the route table. Then we create a front end subnet. Front end subnet is the public subnet because we need a public IP to go outside. And if you are using private, that's fine also. But if your firewall needs to have a communication to outside, you need to find a way like using net gateway or an internet gateway or some kind of public subnet IP and all. So in our case, like the front end subnet is the public one. And so if you are new to an OCI, you can create a subnet using clicking on create subnet button, enter the name like test1, example, choose the subnet type like regional or AD specific. The recommendation is going to be the regional, enter the CIDR. This is the error because it's outside of this one, but in the nutshell is like put 192. And choose the route table. If you are choosing the default, you can always modify it in the later stage, and choose the public and private type depending on which kind of subnet you want to use, and choose the DNS label and security list. So security list is, think of this way, anything coming on OCI cloud is always blocked unless you allow it for test purpose or your production environment. But since this is a checkpoint firewall use case, so we want to ensure that we allow all the traffic from the outside and send it to the firewall to inspect. But if you, in my case, this is a public subnet, so for test purpose only allow all. But in your case, you just allow only required IP or the CIDR. So once you do that, then you just click on create subnet. It will just create that subnet on your console here. So currently we are using two subnet and our hub VCN, like firewall VCN. One is the public, one is the front end, and the back end is the private subnet. So we were covering the firewall front end subnet here, public one, the CIDR of the subnet. Then we are using the back end subnet, which is the private subnet. The same way you can follow the screenshot as well as I just showed you how you can do that. And the front end subnet, since it's public subnet, it needs to have an internet gateway or some gateway to go outside. So currently we are using internet gateway. So you can create a new internet gateway by clicking on this button here, choosing the compartment on the tagging to track the resources. So currently we already have one, so which we just already created here, internet gateway. And the service gateway, which I was telling earlier, the service gateway is responsible for Spoke VM to talk to the object storage and the object storage Oracle service network without going over internet. So that's the reason we are using the service gateway.
Yeah, there was actually a good question in the Q&A about that particular scenario. Like in the diagrams, we show the internet gateway on all of them, but the internet connectivity is not a requirement. We can deploy this scenario without internet access. And the way we get around that is using that service gateway for our access to the API calls.
Exactly.
And then we use the connectivity back to typically to the customer data center to provide whatever access is needed. And then the data center, the private data center, the customer side just needs a connection into the DRG, and that becomes another spoke.
Exactly. Like you don't need to have internet gateway, but since there is a workshop, it is easier for me to connect from outside.
Exactly. Exactly.
Yeah. But in production environment, even the on-prem usually don't go to internet unless there is a requirement for your application or use case. So we were covering the service gateway. So service gateway can be created from here. So if you choose the service gateway, enter the name, choose the compartment, and select which service we want to expose to, like all or on the object storage within your IID region, like S1 region, or once you select a different region, you can go from there. So scrolling this one, I just wanted to focus, like, because in my environment, everything is in S1. So that's where we have created everything. So service gateway, something similar. Then that configuring hub web VCN, like those are spoke VCN, web VCN and database VCN. So in similar fashion, you can create a new VCN here, like creating the web VCN database VCN, which we already created using the Oracle Resource Manager. So which is like web VCN, which has one subnet currently, which is like 10.0.0.25, but the SADA is 10.0.0.24. Then the reason I wanted to skip one of the another SADA like 10.128 part, because is if a VM is sitting in this subnet in this SADA, and if we have another subnet like let me create one, like test one. Okay, so and then this one I just created manually because I wanted to focus on one key use case is like if a VM is sitting in this test one subnet and they are trying to talk to the application private, they won't go outside of this VCN. And since they won't go outside of this VCN, they won't know how to inspect the traffic between those VCN, because the firewall won't even know about this traffic coming from test one to application private. So that's why the recommendation is like if you want to inspect the whole subnet, you assign the whole SADA 10.00/24 to your application private subnet. So in that way, like if you want to inspect the whole subnet, then you can inspect it. But if a traffic between this test one and application private, it won't be inspected, because in our architecture here, if you have another subnet within this web application tier, this subnet will directly talk to this subnet. It won't even go to the DRG. It will just know within this VCN, we allow the routing in a way that they can communicate to each other based on the security list and all. So that's the reason I didn't create this test one earlier. I wanted to focus on that point. All right. So
real quick, Arun, just a side comment. What is I know it's a large number. What is the upper limit for VCN attachments into a DRG? It's significant, right?
Yeah, it's close to 300 VCN.
Right. So before with LPGs, we had a limitation of, I think it was 10 VCNs per attachment. And so this definitely makes things much more easy to maintain and add on to. And the other thing to make a point is CloudGuard, I think, is probably the only vendor that can deploy 2 VNIC firewalls into Oracle. And so it saves you money potentially if depending on how you design your solution, you don't need to deploy more than a 2 NIC instance if you don't want to.
Exactly.
A lot of our competitors require at least 3 to, one for management, and then the 2 interfaces for traffic manipulation and management. We only require 2.
Exactly. So that's why like you can just use the minimum shape, and that will consume less resources as well as the licensing cost also. Exactly.
Yeah, that's actually a good point too. So if you're not familiar with Oracle, they use the term OCPU, and OCPU aligns with 2 virtual cores of checkpoints. So if you have let's say a 2 OCPU shape, that 2 OCPU shape actually converts or actually will show 4 cores inside checkpoint, and so you need to license 4 cores of checkpoint. So you have to do the math on that a little bit. I'll share an SK that actually explains that or talks about that as well, just so you have that in your back pocket if you need it.
Right. Thank you, Jeff. So yeah, so which those subnet level which we're covering. So once with the web VCN is that you can create a new VCN, within the web VCN, you assign the CIDR and all, and then you create a subnet within this web VCN or database VCN. So this is the web VCN part. So you just use this CIDR or assign the whole CIDR to that subnet. Similarly, like which we create the database VCN, which we already have one running. So creating VCNs, new VCN, like clicking on the button, and it comes with the default value. Then the database private, which is a subnet, assign the whole CIDR or a subset of CIDR, depending on if you want to inspect the whole subnet or a smaller subset of subnet. All right, so this is the web VCN. Then we have the similarly like database VCN, one application, the subnet CIDR and all is already being created here. And how do we create the dynamic route? Like we are focusing on the DRG. So this is the next step is talks about how you can create the DRG. So you can search it here, dynamic routing gateway directly. So it will take you to the dynamic routing gateway page. DRG allows you to communicate between VCNs as well as I said, like virtual circuit or IPsec. They terminate there, and based on where do you want to route the traffic, you can define the DRG route table and all. So in our demo compartment, there's already a DRG running based on our automation. So if you want to create one, you can click on this create button here and assign the tagging as per your need. So this is the firewall DRG. So in this case, like a DRG, just showed like you can create the firewall DRG here by clicking on the DRG button, put the name and choose the right compartment, which will come the default value. So how do you attach each VCN to the DRG? So there is a concept within the DRG called VCN attachment. So what we're gonna do, we're gonna assign each VCN to the DRG and as an attachment value. So we go into the DRG here, you would see that there's already 3 attachments because they came from automation. But if you are new to a DRG, you can click on the, this button here, VCN attachment, and choose the VCN from drop down, like where do you want to attach it and all. And these will come the default value, but will show like what are the routing and all being used when the traffic inspection part comes. So, but as well as like for the time being, what we have created like 2 routing table. One is for 2 firewall, one is which is responsible from traffic coming from Spoke VM, sending 2 firewall, as well as there's a routing table attached to the hub VCN, like firewall VCN, which is from firewall, that is responsible for traffic coming from firewall, sending it back to the Spoke VM. So in this workshop, as you follow along, we are attaching 3 different VCN attachment: firewall VCN, web VCN, and the database VCN attachment. So currently we are choosing the default DRG route table, but in the next step, when we are creating the 2 firewall route table, so if you click on the DRG here, click on the DRG route table, you can create a new routing table by clicking on this button here. You can enter the CIDR. You can say how do you want to, what would be the next hop for this CIDR. So you can choose the firewall VCN from here. So that's the same thing which we did for 2 firewall. So if you click on 2 firewall route table here, you will see there's 00, anything coming from the Spoke VM, sending to the firewall VCN attachment, like the VCN attachment of the firewall hub VCN. Same way, we created a 2 firewall route from firewall. So, but from firewall, we are dynamically importing the route. So that's why we attach the import route distribution. So if we click on here, transit Spoke, which you will see there are 2 entries here. One is for web VCN and another is database VCN. We are accepting both those entries. So in that way, it knows dynamically where to send it back the return traffic from firewall VCN to the Spoke VM. So for example, traffic comes from application web, it will go the DRG based on the 2 firewall route table, and it will send it to the firewall. But the traffic coming from the firewall, it will go to the from route table, and based on the transits import route distribution, it will go to the Spoke VM. And there is another route table which is responsible to send the traffic to the firewall. So if you scroll down here to firewall, we are creating here from firewall route table, and we are attaching the from firewall route table to the VCN. And let me show quickly how you can attach it. So if you click on one of the database VCN, click on edit button here. So advanced option, from there you can select the DRG route table, like from firewall to firewall, depending on which VCN attachment you're trying to do. But the route table which is responsible to send the traffic coming from web spoke to the firewall is attached to the firewall VCN. So there is a VCN route table here. If you click on the edit here, click on advanced option. This VCN route table is VCN ingress. So this is present in our hub VCN. So if I click on this VCN ingress route table, it will take you to the firewall VCN. And currently, like you don't need this 00, but since this was automation, I just added it here. If you already have 00, you don't need this bottom one. But in production environment, you want to point it to only spoke CIDR, right? Or any particular CIDR which you want to send it to. So what we are sending it here, we are sending it to the private IP of the backend interface of the CloudGuard firewall. So if we click on this 2.139, if you click on the VNIC here, let me open in the new tab. It should take me to the primary firewall of the Checkpoint CloudGuard and the backend interface of that floating IP, because this is the floating IP. Remember in the earlier I was saying that how we do the HA failover, we assign the floating IP on the backend interface as well as the front-end interface. And once the failover happens, we move those IP based on the dynamic group and the policy which are defined to the primary firewall. So the secondary firewall. We will cover that during our traffic inspection and all. But if you take it quickly, like on the backend interface of the primary firewall, 1.2.139, that's the floating IP. Beside the primary IP, there's another IP, that's why it's a floating IP. But if you're curious where it is attached to, click on the attached VNIC here. It will take you to the CloudGuard 1 firewall. All right. So that's the route table which is responsible to send the traffic to the VCN ingress. So what we cover, the database VCN attachment, DRG route table to firewall, and then import route distribution, which we covered also, creating different entries. So you can click on the DRG here, click on import route distribution. From there you can create, once this is popular, you can create a new route distribution and you can add those different statements based on the how would you learn those dynamic route table based on the attachment value, like VCN, and choose your VCN like web VCN and all, right? All right, so these are the import route distribution which you assign it to the firewall attachment, like so the route table of the from firewall. So this is the from firewall route table, this one here, and you can edit here. And from this one, you can select this import route distribution checkmark, and from the drop down, you can select the transit spoke, which we just created for web spoke and database spoke. So, okay, the next step is configure the route table in each VCN. So this is responsible to how to send traffic to the DRG as well as how to send return traffic. So what we going, as you noticed earlier in the manual step, we were using the default route table, but in this case, we are going to assign the dedicated route table to either the web VCN, database VCN, or our firewall VCN. So let's focus on the spoke VCN first. So this is the spoke VCN here. Click on the one of the web VCN. So if you click on the application private route table, so it has a route table here. If you click on this route table, as you notice already here, there's a target is a DRG. So what we're doing here, anything coming from spoke VM in the web VCN, and the next hop is the DRG. So the DRG, from the DRG is gonna go to the firewall based on the VCN ingress route table and the attachment entry, as well as the two firewall route table. So, but if you are new, you can just click on the add route table here and select the DRG here, and it will know dynamically because of the attachment, and it knows which DRG will be the next hop. And you can pass the CIDR where you want to send it to the DRG and all. But for test purpose, I just allowed 00, but in your production environment, choose only your own CIDR. All right, so that was the web spoke part, and there's another entry which is the ingress, and so this is around the security list. So if you click on the web VCN, if you go into the subnet application private, there's already a security list called allow all. This allow is always currently I'm allowing all the protocol, but in your case, if you want to assign a particular CIDR, you can choose the CIDR value and choose only particular like SSH or ICMP, or depending on which protocol you want to send it to, use TCP, UDP, or anything. But in my test purpose, I selected all protocol for test purpose only. So in that way, I can send all the traffic from Spoke VM as well as to the firewall via the DRG. All right, so that was the database VCN, and this is like the same way, web VCN, the same way which you can do in the database VCN. So we click on the database VCN here. So we have the one subnet. Within the one subnet, we have one route table. Within the one route table, we have the DRG here. So you can create a new entry by clicking on here, based on how do you want to send it to the internet gateway and all. But in our case, since this is a firewall workshop, so we are sending to the DRG. From the DRG, it will go to the firewall. All right. Same way, we are creating another route, another security list within this database VCN, allow all, which has an ingress, like allowing all for the test purpose. And okay, so this is the firewall VCN route table. So there are a couple of route tables which we have created. So let me go into the firewall VCN. So this is the firewall VCN. There are a couple of route tables here. One is for backend route table, software service gateway, and the VCN ingress, which we already covered in the beginning, and the default route table. So if you look at the default route table, which is attached to the front end subnet, it also has a default gateway as an internet gateway. But if there is a traffic coming from only from the interest subnet, doesn't go to the firewall, it can have a route pointing to the DRG also. But in our case, since this is the backend route table which is attached to the backend, and these are the return route from the backend subnet pointing back to the DRG, as well as like any route going to the object storage from the backend. So in that way, it doesn't go to the internet, it goes to the service gateway. So this is the service gateway. And service gateway has its own route table, which is pointing to the same floating IP of the backend. So these are the different route table, like which we covered, like the backend route table, and as well as the VCN ingress route table, service gateway route table. And there's the security list is the same concept, like we are creating another security list which is attached to each subnet, allow all, and which has the ingress for test purpose. I'm allowing all. Then before we have like a break, I just want to focus on like how you can create the launch compute instances in the Spoke VM. So if you go into console here, select the compute instances, and you can click on choose your compartment, click on create instance, and this will choose the compartment where you want to create this compute instance. Choose your AD specific or the fault domain if you want to do. This is the fault domain. So like if you want to select the multiple or 1 or 2, 3, depending on where do you want to put your instance. All right, so what we want to show, like this is the Oracle Linux. This is the shape if you want to select a particular shape, but in our case, since this is the Spoke VM, we are choosing the Oracle Linux operating system, and we're choosing the default value. And this is the VCN from drop down. You can select, you can go to different compartment. This if you choose to, but in our case, all the networking resources are also in demo compartment. So you can choose the VCN. Choose your subnet. As you notice, test one is also populated here, or application private. And since these are private subnet, they won't have any public IP. But if it was a public subnet, you can assign a public IP address here, and choose your public SSH key. You can download this one locally, or you can upload from your browser option, or you can paste multiple key depending on which key you want to edit to. And then there's click create. You can always save that as a Terraform stack and create from here there, as well as you can create directly here also. So I'm not going to create one because I already have the 2 VM in the web spoke and database spoke. But as in similar fashion, you can create a 2 spoke VM in the database VM VCN as well as the web VCN. But for minimum resources, you need at least 1 VM into each spoke VM to test that east to west traffic as well as north to south, inbound and outbound. All right, I think Jeff, it's a good time to take a short break before we move to the next lab environment.
Yep, agreed. Good job, Arun. Any questions? Feel free to put it in the Q&A. We've had been going back and forth with Peter, but that's all good stuff. Peter was asking about how to communicate with the on-prem, or actually in the Oracle Cloud instances without internet access, and we're kind of walking through that. So,
okay.
If you have any other questions, feel free to Q&A. So let's do. Why don't we meet back here at 5 after the hour?
5 after. Okay.
So 5 after. So about 12 minutes.
All right.
Thanks, Arun.
Sure. So Jeff, sorry. Okay, we'll start from where we left off. So as you noticed, like earlier, we were following a manual step just to ensure that all those VCN subnets and instances on the Spoke VM are created successfully. Now, the next step of the manual part was just to ensure that how you understand how you can deploy the CloudGuard from OCI console. So this is the deploy CloudGuard and supporting configuration. As I already told you, you need to have a paid account and access to listings. At minimum, bring your own license listing. So the first one is to support this checkpoint CloudGuard solution on OCI, you need to deploy this manager as well as 2 instances of the CloudGuard. And to do that, as you see in the task one, which focus on the management platform and the CloudGuard instances, and then the task 2 is adding interfaces on all. So we'll focus on the first one for the time being. I'll show how you can search it directly or from the compute instance console. So for example, if you are here already on the create instance, you can select on create instance here and enter your name, compartment, AD, and fault domain, which we already covered. Then change the shape over here and choose the partner images. So once you do that, then it will populate the marketplace images of all the partners. Then search for your checkpoint partner from the by clicking on the next arrow button here. So in your case, this is the checkpoint CloudGuard management platform. That's the one. And another, if you were deploying the CloudGuard only directly, so this is the one. And you can select the version also. So if you're in your case, we are using RAD1 release But if you are choosing a different release, you can select that also for your environment. So that's how you can select it. Like once you select this image, you subscribe to that image by clicking on this arrow button here, then the select image. Once you do that, then it will dynamically know that which image is compatible to this listing and all. So if you see here, if E3 is compatible, but E4 is not, and if you select the Intel shape, so those like these are the compatible shape for this bring your own license listing. So in a nutshell, like if you want to achieve high throughput, and you can see the performance benchmark from the checkpoint which are publicly available on OCI platform, and based on that you can select the instance. But in your case, you would at least need 2.1, because 2.1 requires we need 2 VNIC. So this it supports number of VNIC like 2 VNIC, which we need. So once you select that particular shape, you can select, for example, if you want to change it, you can change it. Then the core concept will remain same. You choose your VCN on firewall VCN side, select the management subnet, which is our front end one for management server, as well as the CloudGuard. Assign the public IP address if you want to assign it and access it from outside. And the SSH key is like uploading public key from browser option or pasting it depending on what you choose to. And then click on create. I'm not going to create it because I already have the management platform as well as the CloudGuard instances are running. But in similar fashion, you can create 3 different instances. One is for management platform, another one is CloudGuard 1 and CloudGuard 2. So in the first task of this lab was focusing on the checkpoint manager, CloudGuard 1 and CloudGuard 2. It talks about which is the release which you selected, what is the minimum shape which you can choose. Same way, repeat the same step for CloudGuard and CloudGuard 2 and all. Okay. And the next task. So as you notice, like when you were creating the first time, I was creating an instance. I can attach only one interface at a time. So it doesn't allow you to attach multiple interfaces for the time being on OCI platform. So there's either you can use the Terraform where you can dynamically add those interfaces and your firewall will know about it. Or you can attach additional interfaces by going on the OCI console. So if you go into OCI console, the CloudGuard 1, select the attach VNIC. So you can create a new VNIC by clicking on this button here. Update the name, which is an optional value, and select the VCN where you want to attach it VNIC to. Choose the VNIC like subnet level because this is for layer 2 VNAN, which is not LA yet at the moment. Sorry, GA. So this is the like a private subnet. You can select those subnet where you want to attach those VNIC, and you can skip those source and destination check to ensure that firewall perform those check value for you. So this is required for firewall use case. And if you want to assign a particular IP, we can choose to. Otherwise, DHCP. It will know dynamically from the DHCP like what's the IP it needs to choose, and you can enter the host name if you choose to. So that's how you can assign a new VNIC to that. So what, as you already know, that we are using Oracle Resource Manager to provision the resources. So in our case, there's additional VNIC is already being attached. And if you select it here, just to confirm edit VNIC here, skip source to destination check is enabled. The name is already being entered here. So same way, like you need to attach secondary VNIC on both of the firewall, CloudGuard 1 as well as the CloudGuard 2. So once you do that, you just save your changes. And the task 3 is focused on how you can assign the floating IP. So as you know, in our use case, we need to assign the floating IP to this VNIC as well as this VNIC, which will be moved to the secondary during the failover. So if you go into this CloudGuard 1, and let's focus on one of the VNIC backend. These are the IPv address, and you can see the assigned secondary private IP address here. So you can assign IP as a dedicated value, or it will now dynamically choose an IP address here. So in our case, like in backend doesn't require a private IP, but if it was a front-end subnet, you can select the public IP from a drop-down as your existing public IP, or you can reserve a new ephemeral IP if you choose to. So in our case, if we already have a floating IP on the backend, let's go into the front end also, just to double check. It should have a private as well as the public IP on the front end.
Also, one thing quickly to add is that you can have multiple floating IPs. You're not restricted just to the one virtual IP for the cluster. You can have additional floating IPs that can be used for, statically netted items or other public IPs, et cetera, that you want to hide net behind, et cetera. So you're not restricted to one floating IP.
Correct, because one VNIC allow like multiple secondary IP, so you can assign another IP from the drop down here. And correct me if I'm wrong, like Jeff, once the failover happens, all those multiple secondary VNIC IP moves over, right? Jeff? Okay, so I think he's on mute. So yeah, you can assign the secondary IP from the drop down here. And in our case, the front end needed a floating IP as well as the public IP. So if you see there's a public IP assigned to it here.
All right, I'm back. Sorry, what was the question, Arun?
So for example, if you have multiple secondary floating IPs, they all will be moved during the failover, right?
Correct. Yes, the
Correct.
the script that we run that checks for any secondary IPs, and we'll move all of them over on a failover event.
Okay, so yeah, so and one of the use cases, for example, if you have multiple servers and you want to access them into different public IP, and that's where you can assign the public IP as well as the associated private IP to the same VNIC. All right, so in this workshop, this task was focused on around the secondary IP address, which we covered, like how you can assign the private IP as well as the public IP on the front end and the back end interface. And one thing which I wanted to focus, like if you go into CloudGuard 2, you won't see those public IP as well as the floating IP, which we focus on the CloudGuard 1. So if I go into CloudGuard 2 here, click on the attach VNIC. So there is no floating IP on the front end, as well as you should not see on the back end also. So that's the because since this is the secondary firewall, it will know only on those IP once the failover happens. All right. So this is the task 1, task 3, failover IP. Okay. So one thing which is dynamic group and the policy, which I was focusing during the Oracle Resource Manager. So if in the behind the scene, in a nutshell, what it has all those CloudGuard 1 and CloudGuard 2 instance OSI. So if I go into my OSI console here, dynamic group are created on the root compartment level, and wherever you put that compute instances as well as the network resources, you have to ensure those policy gets populated all the way to your compartment. So in our case, the dynamic group is the demo 1, which we are using. And these are the instance OSIs. So if I go into one of the instance like CloudGuard 2, which is ending with the J2A, and you would see like J2A is here. So another one is the CloudGuard 1. So you assign those dynamic group. You can create new dynamic group by clicking on here, and then you can use the rule builder as an example and choose the instance OSIT, and that's where you can enter the value, add another line and all if you choose to. And then you refer this dynamic group in your policies. So if I click on policies, choose my demo compartment within I have to put that policy, something like that. So like allow dynamic group, CloudGuard, HA dynamic group to manage all resources in compartment demo. So since my networking and compute resources, they are all in the same compartment, it will know and as well as like in my dynamic group, I only 2 OSIT, the CloudGuard OSIT. But in your case, if you want to restrict to network resources, you can do that also. And for that, you can follow this. Each section has its own like a guideline, like learn more. It will point you to the official page of the checkpoint deployment guide on OCI. All right. So we will focus on the dynamic group. You can create the dynamic group, and then the policy is the same way. You can assign the policy, or you can create a new policy by clicking on this button here. You can enter the manual editor, put the policy, what the policy looks like, or you can select the policy group. It depends on different compartment or resources and all. But in our case, it's just we are allowing based on dynamic group and a group name, and to manage all resources in which compartment, the demo. So, okay, at this point, like dynamic group, everything is there. So the next part is like updating the route table, which we already covered, but behind the scene, like if you are curious, you can just go into each VCN just to confirm all the routing tables are there. So for example, in firewall VCN, we have like a couple of routing table, and each routing table is associated to their own entity, like subnet level or the service gateway or the DRJ level, depending on which route table you're attached to. For example, backend has its own route table. If it is not there, then you can always edit it and choose the route table from drop down here. So this like task 5, which talks about updating route table, backend route table, VCN entry, default route table, service gateway, which is like the backend floating IP and all. And the task 6 is just a sanity check, just to ensure that you have the correct routing in a way that any traffic coming from north to south or east to west goes to the respective resource where it needs to. All right. So at this point, like I have got pretty much in detail, like what's the lab 1 and lab 2, even though we didn't go through the manual creation process, but I have covered like what are the required resources to deploy this workshop, like a hub VCN, spoke VCN, subnets, route table, DRG attachment, DRG route table, and on the subnet level, like security list, as well as creating spoke VM, as well as the hub VM or like a CloudGuard firewall, as well as the CloudGuard security management platform. All right, so let's move to the next step. So next step is like, since we did the Oracle Resource Manager, we said like you can go to the lab 3 directly. So we're gonna go into the lab 3 now. All right, so the list lab 3, which focus on the what are the prerequisite, not the pre, what are the minimum required configuration before you can use the smart console as well as the manager platform to manage the firewall, right? So to access the management platform, we're gonna do some initial configuration on the checkpoint management platform. So what it said, like the initial configuration is just like setting up the admin password. So in that way you can access that using browser, using that password which we're gonna set it up. So go into OCI console here, go to your instance, choose the management platform IP. In my case, it's a public IP. Then just enter this command to enter a unique password. In my case, I'm choosing the value which is mentioned in the workshop. It's check at 123. But I would encourage you to use your own password. Save config. Okay. So this will allow me to access this instance using this password on OCI console. Sorry, on our web browser. Since I already have security list open, so I can just go directly here. So enter the admin user. Let me just go admin. Okay. So what we're going to do, we're going to follow the initial wizard to set up this instance as a management platform. So you would see like some screenshot available in the workshop also. And if you want to just understand, you can understand what I'm doing it here. So click on next. Continue with the R81 release. Click on next. And we're going to choose the value which are populating coming from our DHCP configuration on the instance, like 177 IP. We're not going to change it. Click on next here, update the name. So checkpoint manager. If you want to point to a different DNS, you can point to those DNS, but I'm keeping the default value here. Keeping the default value for the time zone also. This is important because in the next step, you will see like we are setting up this instance as only security management, not as a security gateway. So you're going to unselect this check mark, which
that's a really important step there to uncheck security gateway. If you leave security gateway there, it'll still work, but it will cause you some headaches at some point because it's going to be acting like a firewall as well and block some traffic. So if you're just doing a security management by itself, make sure to uncheck that box.
Correct. Then click on next. Sorry, click. Oh, what did I say?
It's just the contracts thing. Yeah, you can leave it checked.
Next, then I'm going to choose only default value, which I already admin and the password which I entered. But if you want to create a new for your UI, you can create a new user and all. I'm going to allow all IP, but if you want to restrict only your own machine, like public IP or some certain subnet to access this GUI, you can restrict that. Okay. So once you click on finish button, which will just start deploying those configuration which we selected, and click on yes.
Yeah, and one thing to point out for those of you that are checkpoint veterans, obviously this is not a requirement if you already have a security management server. Obviously, you're not required to use the security management, from Oracle. You can use your own on-prem or SmartOne Cloud, etc., or from another cloud. We're just doing this obviously for the purposes of the workshop.
Exactly. And just because you already have management platform, you can always access it from those platform, and as well it's not required to have. But for just to understand how the checkpoint solution overall looks like, we are deploying each individual component for end user visibility.
Yep, exactly.
All right. So in this one, like the workshop, the first task was just management platform. These are the same screenshots which we just covered, like interface IP, checkpoint host name, NTP, and making sure that it's only management platform, update, keeping the default admin user IPs, and just finishing the first time wizard. So once you do that, then behind the scene, you will see this kind of window. All right, so we will move to the next task while it populates here. So the next task is how we can manage the initial configuration on the CloudGuard Security Gateway primary as well as the secondary one. So the same way we need to set up the admin password on each instance. So let's copy the CloudGuard one first. I'm keeping the same value, so because it's easier for me, but you should use your own unique password. Okay. So same way you can enter the admin user and password. So if you see from the console here, like the workshop, we enter the admin password which we want to use, connect to the GUI, and you will see this window in a bit. So if you see here, so in this window, what it tells is a couple of comment here. One is like you can update the host name. You can update the admin password if you choose to, new password or confirm password. And this is important. The SIG key is responsible for management platform to communicate to the CloudGuard Security Gateway 1 and 2. So this has to be unique, and this is responsible for trust communication between management and firewall.
Right, and it's a little bit misleading. It's not really activation key kind of makes it sound like it's a license, but it's not. It's just a one-time password essentially that you use when you connect management to the gateway.
Correct. And if you miss that, then you have to go into, you can follow the knowledge base article from Checkpoint. There are many articles which tells you like how you can set it up. But it's pretty important you remember this key because it will be used during the management cluster creation. Sorry, management platform to use the cluster. Yes.
Right.
All right.
And then real quick too, this password here, this can be the same password that you set earlier. You don't have to create a new one.
Correct. So that's why I'm keeping the same password. I'm not updating the new one. And this is the CloudGuard one. And I'm also keeping the SIG key same as the password for my test purpose only, but you can use your own unique SIG key. And make sure this you enable this configuration because our CloudGuard 1 and CloudGuard 2, they will be acting as a cluster, right? So you can mark this button here, and if you forget it here, then you have to do it from the command line afterwards. Okay, so what's going to happen like it's going to push all those SIG key and configuration which we are doing it here, and then after that it's going to reboot. So we just collect yes, then in a way that we can move to the CloudGuard 2 in meanwhile. So select the CloudGuard 2 here. I'm not passing my private key because it's already added into my SSH terminal. But if you want to use, you can use your own private key with the I flag and all. All right. The same way you go into browser and set up the initial configuration. So this is you would see the same window, and then update the host name, CloudGuard 2. This is the same password which you are keeping here. Check 1, 2, 3. And check this mark. All right, so once you do that, just select yes. So it will do the same way, like it's going to reboot the host and apply the configuration. In meanwhile, like this is the the management platform, which is currently populating locally. So while this management cluster as well as the CloudGuard Security Gateway comes up healthy, and there is a next step, which is a short step, which I can focus. So as you already know, we were following the task 3 by the CloudGuard 2. We did the initial configuration of CloudGuard 2, and it's currently rebooting it. We'll move to this next step after once the host boots up successfully. But in meanwhile, there's a task 4, which is a smart console. So currently, like how you connect to the management platform, you use the smart console software provided by Checkpoint, which allows you to connect to the management platform. So this smart console is like a Windows application. So you need to have a Windows VM. This Windows VM can be your own Windows VM or any virtual machine also, as long as it has a reachability to the management public IP, which we created. Or if you are using any in-house, you can create a new instance. So that's what I was doing during the break. I created a smart console VM, which is based off on the Windows 2019 server, and I'm going to use that VM to install that smart console server. So
Yeah,
what
and
I can do,
the smart console application. So it can live really anywhere as long as that Windows device can reach the management server.
correct, exactly. So this smart, since we are this management platform is up yet, but this the CloudGuard 1 and CloudGuard 2, they are still coming up. So what I can do, I can copy this link here, copy link address. Let me share. Let me know if you can see my this Windows VM, Jeff.
Yes, I can.
All right. So what we're doing, we just pasting the smart console, which from the workshop part only. So I'm just gonna click it here and download. Let it download. So this smart console will allow me to connect to that server management platform, and from there I will be able to push the policies and the required network object configuration and adding the cluster and all. So any question meanwhile, like in a way that needs to be answered?
You're doing too good of a job, Arun.
Thank you, Jeff.
That or we need more caffeine. That's okay. The interesting parts are coming up, or more interesting, at least on the checkpoint side, the failover and the traffic validation, et cetera. So we're also trying to show that it's not too bad. It's pretty slick.
Install.
And I'm guessing a number of our attendees are checkpoint veterans. So some of this is
Pretty normal.
yeah, pretty repetitive and nothing outside the norm. So we'll get into the cluster bits here in a second.
Exactly. So let's see.
We could take a short 5-minute break while things get booted up here.
Okay, let's do that. Let's
Because the services take a little bit to start up with management too after a reboot. So we can take a quick 5-minute break. So let's start up again at 40 minutes after the hour.
all right, sounds good.
All right. Thanks, Arun.
Thanks, Jeff.
All right, Arun, shall we get started?
Yep, Jeff. All right. Thanks, everyone. So what we covering in the last step, we were focusing on the initial configuration of the instances. So we applied that and the host was rebooting. So if you see this CloudGuard 1 and CloudGuard 2, they both were rebooted successfully. So if you go into our workshop, before we go into the Smart Console and also let's move to the task 2. So in the task 2, we were doing the initial configuration of CloudGuard, which we just did. Host was rebooted after that. And then we need to add a static route. Okay. So why do we need to add the static route is think of this way. In this backend interface, if it knows about the backend subnet, right? But it needs to, the firewall itself needs to have a route to send it to in a way, for example, if a spoke VM wants to talk to, right, on the backend. So it needs to have a route. It says like anything coming towards the spoke subnet, it needs to follow the backend subnet gateway. So to support that, as you already know on OCI, the first IP of the subnet is the gateway. So what we're gonna do, we're gonna create a static route on the both firewall, because the static route, they don't move from one firewall to another one. So you need to have on both firewall. So in that way, like static route will be like anything destined to the spoke VM CIDR needs to follow via the backend subnet gateway. And once it comes here, the backend subnet, it has a route pointing to the DRG, and from the DRG, it will come to the spoke VM. So to do that, we had to add in this static route. So what we're gonna do, we're gonna connect to each spoke, each CloudGuard security gateway. So let's connect here. So in the CloudGuard 1, so if there's a configuration log, you can unlock it, but currently it's not there. And then click on add button here under IPv4 static route. So we have 192.168.1.1. 1.0 is the front end subnet and 2.1 would be with the backend. If you are curious, you can go into an OCI console, click on the VCN here, click on the firewall VCN, and you would see the front end is the 1.0 and the backend is 2.0. So the first IP is the gateway, but that's why it's seeing the 1.1. And in our case, we're going to point it to 2.1. So you can choose your own CIDR like a 10.0.0/24 or 0.10/24, but I'm putting for generic value at the moment, like /16. But you enter your own unique value, which you want to point it to the backend subnet gateway. Click on IPv address 192.168.2.1. Correct. So now it has a route entry pointing the spoke CIDR via the backend subnet gateway. Similar way you do it on the CloudGuard 2. Same way, CloudGuard 2, IPv4 static route. Click on add here. I'm currently using the GUI, but you can follow the CLI on API, whichever you are familiar with that. Okay, cool. Now both firewall, they have the route pointing the spoke CIDR. And if you were using the, for example, service gateway as we were focusing, so you would need another route for this object storage CIDR. So that's available on OCI public document. What is the CIDR for in each region? You can use that value also for service gateway use case.
One thing to add real quick, that's not a part of the workshop, that's just kind of a general checkpoint best practice, and that we don't include by default any images at this time. It will be, I think we're going to plan on doing that here soon, is the application of the jumbo hotfix. So as with anything checkpoint, we recommend that you apply the latest GA jumbo, and that's still the case. So We are not doing it as part of the workshop, but just in general, it's a good idea to do that regardless.
Yep. So let me, since Jeff just mentioned what is the recommendation, so let me quickly search that recommendation. Where did that go?
Yeah, the first one's the newest
First
one.
Yeah. All right. And before we move to the next workshop task, I just wanted to focus on one of this very quickly. So if you see here, so Checkpoint also recommends like you deploy a dedicated like a North Hub firewall as well as the South Hub firewall. South Hub is for east to west traffic. So you have like you can deploy them into an HA cluster. For the North Hub, you can deploy them in active using the external network load balancer. So you deploy them in, there's a reference architecture which is written. I will share that in a bit on chat. But the idea is remains same. You have the DRG to communicate between VCNs. Anything coming from internet, they will go to the NLB, go to the one of the firewall. This is for north to south only. But anything coming from between spoke PM east to west or going outside, they will follow the DRG and go to the backend subnet via the VCN ingress route table. So if you are curious, like what is the topology looks like, you can you can refer it here, and there is an automation also available which you can deploy it locally, and it tells you like what is the traffic flow will look like and all. The only caveat is like current supported of NLB use case is like you need to have source net on the firewall when the traffic coming to the spoke VM from north to south. So this spoke VM, they will see traffic is coming from the backend IP instead of the your original source IP. But that will change in future. But the current supported use cases you need to have source net on the firewall for the active use case, but active passive now. All right. So we created this static route on the CloudGuard 1 and CloudGuard 2, which was successfully created. Then we were focusing on the smart console. So let me go into my remote desktop one more time just to see. Okay, it was successfully installed. So let me just click on here. Okay, now just enter the admin as well as the user for the management instance, security management instance. So let's choose the IP of the instance. Okay. So the simple idea is the smart console application allows you to connect to the management platform. So click on proceed. And from there, we're gonna create a new cluster, add those CloudGuard 1 and CloudGuard 2 in that cluster, import the topology of like IP addresses and all. Then we're gonna create policies as well as the net policy for our north to south or as well as outbound traffic. And we're gonna create some object to connect those web spoke VM and database spoke VM.
There was a question in the Q&A about auto scale support. Today we support static scale sets. We hope to have auto scale supported in Q1 of 2022.
Exactly.
For that northbound hub.
All right. So this management, you'll see some small pop-up window was new here. You can close it if you choose to, or you can read it. All right. So what we're going to focus now, we connected the smart console. We're going to create a new cluster. So we're going to follow along this workshop in a way that you understand like how to add a new cluster and where to get the IP and what IP needs to be added there, right? So click on this icon here, click on cluster, create cluster. Then we're going to follow the wizard mode. So in a way, we know what are the different objects which you need to edit here. Okay. enter your cluster name. So this will be checkpoint cluster. Enter the cluster IPv4 address. So what would be the IPv4 here? So if you follow the workshop here, it says enter secondary public IP address associated to primary, which is a front-end interface of CloudGuard 1 instance. So if we go into CloudGuard 1 attach VNIC, the primary interface is the front-end one. And this is the public IP address, which we have it here and which we need to add into cluster. And correct me, Jeff, if I'm wrong. This can be private IP also, right? It doesn't
Yeah,
have to
this
be.
particular IP is not super critical. It's more just a placeholder. You would use that IP for VPN definitions or other and high NAT, etc. So this really can be just about anything.
Okay, sounds good. So click on next here. So once you do that, then and the next step we're going to add the cluster member. So click on add, click on new cluster member. So CloudGuard 1. Okay. So if you see here, we just added the first IP, and then we created a new cluster CloudGuard 1, and we're going to enter the IP. So what's the IP will be? Enter the primary interface private IP address of the CloudGuard 1 instance. So we go into CloudGuard 1 instance, which we I think we are already on the CloudGuard 1. Let me double check. Okay, primary interface private IP address. So this will be the 1.158. And then this is a SIG key, like secure internal communication key, which we've been talking about. It has to be unique when we created during the initial configuration of CloudGuard. So enter that value. Okay, click on initialize just to ensure that this SIG key is correct and this management platform knows how to communicate to the CloudGuard 1. Okay, you would see the trust established. Then once you see that, then you can just click on OK. And the CloudGuard 1 will come here. Okay. Similarly, you create another member here, which is CloudGuard 2. Click on instance, CloudGuard 2, front-end VNIC. Same way you enter the SIG key here. Click on initialize. Okay, click OK. So at this point, you should see both of the CloudGuard 1 and CloudGuard 2. Just double check that piece. CloudGuard 1, CloudGuard 2 here. And you will see the trust everything is working fine, like the trust is established. So that's the same thing which you see in the workshop outline here. We making sure the trust established is there. CloudGuard 2 you added here, making sure the trust established is there. This is the sanity check just to see, okay, all those CloudGuard 1 and CloudGuard 2 here. So once you go into the next step, we're going to do the finish button. Click on next and finish. So at this point, you would see both members as well as the new cluster is being created here. So you can see here, currently it's not pushed, we didn't publish the change, we didn't install the policy, anything like that, but we're going to do it in like next step and all. So the first step is like, the next step is like you need to populate those interfaces and IP addresses from CloudGuard 1 and CloudGuard 2, right? So what you're going to do, you're going to double click on this checkpoint cluster here. It will take you to go to the network management. Click on get interfaces with topology. So in that way, it will populate the IP addresses as well as the different interfaces on both CloudGuard 1 and CloudGuard 2. Yes. Okay, so you will see the CloudGuard 1 and CloudGuard 2, they have their own unique IP on each 0 is the front end, each one is the backend interface, right? 2.33. So the next step, which just tells you like you need to enter those floating IP on each cluster member, right? So we need to enter the IP address on this virtual IP. So what we're gonna do, click on each 0. Select the network type as each 0 is only for cluster and not for the HS sync and all. So front end IP will be the floating IP. So enter the secondary private IP address of primary interface on the CloudGuard 1, right? So go into CloudGuard 1. This is the front end is the primary interface and the floating IP, right? 1.153. Okay. Click OK here. Click on the each one. Each one will be the cluster plus HS sync configuration. So this will be the secondary floating IP on the backend. So click on the backend here. Okay. So both of the floating IPs are there, as well as we already, based on the topology, it populated the exit IP of the primary interface also, as well as the primary IP on both the interfaces. Click OK. You can continue.
That's okay. Yep.
All right. So we just saw this, we just populated each 0 and each one. This is the one of the policies. So what we're going to do, we're going to modify the existing policy. As you know, there's a cleanup rule which by default block everything. For test purpose, we're going to modify that rule to allow all. But in a production environment, you just allow what you need to do for your use case. Accept, and we're going to enable the tracking, so in that way when logs get populated when there any traffic hits that policies and all. Okay, so at this point, as you see, we are in the last step. If you want to do sanity check, you can do it, but I'm following the workshop, so it's pretty straightforward. So what we're going to do, we're going to first publish our changes, then we're going to install this policy on those each individual cluster member. Click on publish.
And for those of you not that familiar with Checkpoint, publish is essentially just making, committing the changes to the management server. That is not actually pushing anything to the firewalls themselves. The install policy, as he mentioned, is what we'll do to actually push those changes to the firewalls, which then activates the cluster and activates the security policy.
Exactly. All right, so now we do install policy here. And you will see your cluster member which we are trying to install. You can see the policy target if you choose to, or you can see the V changes, what are the changes I'm going to push to those cluster member. So once you do that, you just install it here. And in a bit like this, you can see on the task manager, you can see the progress, what's the like what's the progress looks like. If there is any error and all, you can read it from here and you can do troubleshooting. But for our workshop, it's pretty straightforward. It should pass. So what we did, like we did the publish one, publish and install. This is the publish install. At the same time, you can do both. But what I showed you, like you can do publish first, then install also. All right. So as you see, our changes got successfully applied, and our cluster, they will turn like green in a bit, like give it a couple of seconds or minute. So once it happens, you would see those check mark on each cluster member, right? So that concludes our lab 3, which was what was the initial configuration, how to install the smart console, and how you can configure the new cluster, add those cluster member to the cluster, and populate the initial topology of the interfaces, and assign the floating IP and the initial policies and all. Okay. Now the fun part is like next part focus more on like traffic validation. So which is like how to inspect the north to south, inbound, outbound, east-west traffic. And we're gonna do HA failover also, because for HA we already created the dynamic group and policy. So it's pretty straightforward, it should work. So what we're gonna test it out from the north-south first and then move along in the next step. All right. So to inspect the north to south traffic, the intention is, and since I'm trading on the internet, my intention is to connect to this web spoke VM or database VM from outside. So how would I connect it? So as you know, this front-end interface, it has a secondary IP, which has a public IP associated with that, right? So what I'm gonna use, I'm gonna connect from outside to the public IP. But that public IP will be connected to different port, because I'm going to use the different SSH port to go into either web VM or the database VM. So that's why it's a north to south inbound traffic. To support that, we're going to do some netting in a way that this port, which I'm trying to connect from outside, like 177 port or 1778 port, gets translated to each individual VM as well as the unique SSH port. So for that, we're gonna create some object, network object, like is like the address object as well as the service object on the firewall, as well as some net policy, which you will see in this task. So this north to south, as I mentioned, the current object will be like web app VM object, as well as the front end private IP, because this IP will be public, but as soon as it hits the within the VCN, if that gets translated to the private IP of the front end, so firewall will see this private IP. So we need to have that a network object into the firewall. All right. So if I go into Smart Console here, we will see all those, everything is green marked. So everything is ready to move to the next step. So what you can do, create the network object either from GUI or from the CLI also. There's a command line here, or you can use an API which you are familiar with that also. Since I'm using the GUI, I'm just going to click on network host. We're creating three network objects. So let me populate first value, web app VM1. And the IP address of web app VM1 will be the instance, and select the web app VM1 IP 37. Okay. And you can create a new object also, or if you want to clone, so in that way it knows you don't have to repeat the same click button. You can clone it. This clone value will be the database VM. They are setting on a different two VCN. That's why we're going to connect to each VCN, each spoke VCN from outside. Okay, there's one more object, which is the front-end private IP, which is associated to the floating IP. So you can click on here. Okay, so this private IP is on CloudGuard 1. Go to the front end, front end. So in our case, we're going to use this public IP to connect from outside, but this public IP will be translated as it hits the VCN to this IP. So for that, we need this object here. Click OK.
And as you can imagine, this would be one, a particular use case where if you wanted to have independent IPs for individual devices, you could do the additional floating IPs here.
Yep,
but for the purposes of, but for the purpose of the workshop, we're just going to do the single IP and then just differentiate via NAT translation.
Exactly. So okay, so these three objects which we focus on, like network host object, which is just created web app VM1, front end private IP, which we just created by cloning it, database F1 VM also. And as I said in the beginning, like I'm going to use unique port to connect from outside So it goes to the database VM or the web VM. So this port will be TCP 177 port and 1778 port. So for that, you can click on new, more services. You can use the command line also, as I mentioned before, but I'm just going to create it here. All right. All right. Now at this moment, all the network objects are there. Now we need to move to the next step, which is the policies, right? So you would say we just created web app 177, 1778. Before we move to the policy, we're going to assign a John on our front end. So which allows you to ensure that you can refer the John on your net policies. So to do that, you go into cluster. You go check one cluster here. Click on network object, sorry, network management, click on E0, modify to use specify John, external John here. All right, so we already enabled the logging in the last step when we were creating policy. So these are the net policies. So the first net policy, like to ensure that there is no netting happens on the manager platform, management instance level. But the second and third one is to ensure that anything coming from outside, when it gets translated to the front end private IP, and if you're using any unique TCP service like 177 port or 1778, it gets translated to web VM and to the unique port like SSH, as well as the database VM to the SSH. So that's why we had to create these two policies. And the first one is to make sure that this netting doesn't happen on the management instance IP itself also. So for that, you go into security policy, click on net, select role to top here, and let me just choose this name here. Checkpoint manager, because in our case we enter the manager name with checkpoint manager, that's why it's a different name. And everything any original, keep it default value. Okay, let's move to the next step. So you can add in another role as below, and enter the traffic to web VM app VM1. Okay, so original IP will be, as I mentioned, it will be external John. Original destination will be front end, because it's our firewall will see this front end private IP. Service will be our web service, which is the TCP 177 port. Translated source will be our web VM. Sorry, not translated source. Source will remain the original value once it gets into that one. It won't be different. Okay. Translate destination web VM. Like same way, either if you want to copy, you can copy paste, and which will paste something in below, or if you want to create new one, you can create from the drop down here. But I'm just gonna go do copy paste. So this is for database VM front end. This value will remain same. This will change. So let me just remove it here. DB. So at this moment, we have the network object as well as the policies for net policy as well as the regular policy, which is allow all. And what we're going to do, we're going to publish our changes and install those policies, which will allow us to connect from outside, which we're going to test it out, right? So publish your changes. And click on policy and click on install policy. So while it installs, let me grab the floating IP, public IP, which we're going to use to connect from outside. Oh, it's not admin, it's an OPC user. All right. So the first, since this policy got successfully applied here, as you see, based on that policy, the intention was for us to connect from outside using this floating IP. So if you follow the topology, we are here. We are using this floating IP to connect from outside to the web spoke VM and the database VM. So to do that, as you noted, like I was using this floating IP, and on the particular port 177, which went to the web VM. This is a 0.37, as well as 1778 port, which went to the database VM, and which is 1.188, right? So if you go into instances here on the demo compartment, and you would see like those are going to those respective VMs. So that's the first task of this traffic validation. The intention was just to show how you can use the checkpoint to ensure any traffic coming from outside, it follows the path which we are trying to do via the DRG and goes to the spoke VM and all, and it reaches to the spoke VM and traffic gets inspected with the firewall. So to test that, like on the log level, you can go into the policy, go select the logs here and choose the port, like port value 177. So 177, which will tell you like what we're trying to do from outside. This is my public IP. So currently, like we are using TCP 177 port to connect to the web VM. So as you see on the net rule, it hit that rule which we defined, and it got translated to the port 22. And it is following to the only one firewall at the moment because that's acting as a primary firewall, and secondary is the standby. So there's the north to south inbound traffic, and if there are no questions, then let me just move to the next step, which is that outbound traffic. So to support that outbound, let's just test out if our VM can reach from outside. Currently routing, everything is there, but since the policy are not defined on the firewall level, you won't be able to connect from outside to outside. So we know we have this policy, but this IP is our private IP, right? Those need to be translated. That's why we need to get the net translation. So if you see this task here, so what we're gonna go into each object of the VM object, and we're gonna do the hide net on those objects. So you can search those object here again. And those objects will create an hide net rule here once we enable that option. Click on net here. Click on OK. So it will add an entry here. As you see, just added entry on the hide net. Similarly, you create another one for database VM.
And for those of you that aren't as familiar with the checkpoint, you can do those for an entire network as well. So you don't have to do individual devices or individual
Correct.
You know,
I think
adding
on zone
definitions,
level
but-
also you can define that, right?
Yep, correct.
So you just publish your change and install the policy after that. Okay. So you would see like and now the outbound traffic is also working fine. So we covered like north to south inbound, which is using the particle port and the net on the firewall, as well as the hard net on the VM level. As Jeff mentioned, you can define on the network level as well as the zone level if you choose to. So that covers two of the tasks of the workshop, which were like north to south inbound and outbound. So now the next step is like what we want to do. We want to inspect the traffic between web VM and database VM, right? So to web and database, like intention is we're going to do a ping from here to this, it will follow the DRG path, go to the firewall. From firewall, it will come back to the backend subnet gateway, comes back to the DRG. From the gateway, it will come to the database POC VM based on the attachment and the from firewall route table, which we have. And then therefore it will follow the same path back to the DRG and all. So the intention is, since we already have the static route on the CloudGuard, so this CloudGuard backend interface as well as the firewall knows how to reach to this POC VM via the subnet gateway, default gateway. So let's just test it out because the policy is already there on the firewall policy. So there is no explicit policy which you need to do. Since we are already connected to the VM, let's just cancel the here IP address. Okay, so grab that IP address from, try to ping from web to database. This is web to database and this is database to web. So ping is working as well as if you want to verify on the log level, on the firewall level, you can select it here and service CMP.
I would do echo, yeah. There you go.
So there is one is for database to web, another one is web database, and they both are going to the same firewall. Like this is the primary firewall. If you're curious, you can select and test it out, like what is the, which interface it is hitting. As I told you, like based on the static route, it is hitting the each one interface, and from there, it is coming back to the DRG and the routing and everything is already there. All right. So based on that one, we covered the task one, which is north to inbound, outbound, and SPOC VM. There is one additional step, which is for service gateway, and you can follow the step. I'm not going to cover that, but the intention is still the same. Like you define the object, define a bucket, add an object there, and you define the static route. So these are static route are to ensure that traffic destined to object storage doesn't go through the default gateway of front-end subnet. It follows the back-end subnet default gateway. That's why you need to add those static route on both of the firewall. And once you do that, then you can, there's already route here, which you already have. So once you do that, like you will see like you can connect to that object directly from the each VM. And once you go into the firewall level, you will see how the traffic is going to which interface. It's following the that particular each one interface, which is the backend interface, which you will see from the firewall level. All right. So that was the traffic part, and I wanted to cover the high availability also. So we want to ensure that traffic gets failover from primary to standby, IP moves, as well as the traffic resumes on our ICMP level or any traffic which you're trying to access the application and all, right? So the easiest way to test it out, we already saw in the beginning that the CloudGuard 1 has only floating IP, CloudGuard 2 doesn't have it. So in R81 release, like there are some certain prerequisite step and just only for this release, and Jeff can comment more. Like these prerequisite are like running this command on the expert mode level to ensure that HA failover works fine.
Yeah, it's just a temporary workaround. So we have the certificate bundle, or the certificate was updated on the Oracle side, and so we need to update our side to make sure that the API calls continue to work. So this will be merged into the default image going forward, but right now we have to add these two little lines there to make sure the API calls work correctly, and that has to be done via expert mode.
Exactly. So what we're gonna do, we're gonna go into each instances and go to the expert mode. For that, we need to create an expert password also. So let's go into one of the instance here. This is CloudGuard 1. So all right, so now these both scripts are successfully completed on each CloudGuard instance. If you want to stay in the export mode, you can do that. But for HA failover, I have added some command outside of expert mode, but you can always enable it from there if you choose to. So how would you do an HA failover? Like first, like on either you can reboot the instances for test purpose, or you can do a failover from the command line. So what we're gonna do, we're gonna go into primary instance and we're gonna bring that cluster member down. So this is CloudGuard 1. So if you see the cluster state, CloudGuard 1 is currently active and CloudGuard 2 is currently standby, right? And there is some traffic is running from Spoke VM, one Spoke VM to another Spoke VM, which will make sure that the traffic resume. At the same time, you should see the IP moves over from the OCI console. So if you go into CloudGuard 2 here, attach VNIC. Let's just focus on one of the VNIC here. Okay, so there is no floating IP. So we should see when the failover happens. So we should see the floating IP moves here along with the primary as well as the public IP, which we have. So this is the workshop part. Let's bring the cluster member down, the primary active one. Okay. Okay, so as you see in this CloudGuard 1 status is down, and if I go into my CloudGuard second firewall on the CLI level, you would see this is currently active. CloudGuard 1, 2 is active, and the CloudGuard 1 is down. That's acting as a standby, obviously, and because the second one became primary, and as soon as we bring it up, then it will become his standby. All right. So what we want to focus on, like we want to see the floating IP gets okay. As you not just saw that floating IP got moved to the CloudGuard 2 instance, the VNIC. If you go into secondary and primary and like the backend also, you would see that IP also moved on the backend. So those IP are moved based on the instance principle and the API plugin, which Jeff talked about, which allows to connect in OCI API and to move the IPs and all. And at the same time, we should see that our traffic gets resumed. So there might have been some drop during the failover, but the failover got resumed and the traffic is working fine. There was some packet drop because of the failover which used during the API move. And Jeff, correct me if I'm wrong. Like how long it takes to API failover?
It's pretty darn quick in Oracle. So it's, in some of the tests we've done, we've seen under 10 seconds, but I could say up to 20, but I think what I've seen is under 10 seconds.
Okay, sounds good. And if you are curious, like once the traffic was following, so let me just click it again. So as you see, CloudGuard 2 took over the traffic. So from the ping traffic, which were coming from database to web, as well as the web to database, is now going to the CloudGuard 2. And if you are curious, like if you want to bring the CloudGuard 1 instance up again, you can bring it up like admin using the admin up command. But once you bring it as an up, it will always be in standby. Yep, the CloudGuard 1 in standby. So that was the next step of HA failover, which we just tested it out. Like HA failover works fine as expected. And the next step is like destroying the environment. I'm not going to focus, but it just since that's not the intention of the workshop to destroy the environment. Intention is for you to get familiar yourself with the workshop and solution. But if you choose to, you can follow this lab environment to destroy it if you choose to. Next check.
Good job, Arun.
Any questions, like any comment or feedback? You're always welcome to send it to Jeff, me, and Arian.
Yep, I'll put our email addresses in the chat here. And happy to help, afterwards, offline, et cetera, if you have questions or concerns or architectural questions. Happy to help.
Is there anything here which you feel is OCA specific? Like the DRG is definitely dynamic routing gateway, which I talk about, which allows you to communicate with VCNs. And what else?
I feel like the performance, the price performance is pretty strong.
Pricing, performance wise, yes.
That's something that I would definitely take a peek at if you're comparing.
We haven't covered other services,
but full Terraform support is pretty slick, like native Terraform support.
Correct.
And it's really nice. Like the entire, all the automation is based on Terraform.
Exactly. And that Terraform ORM now supports the Ansible also. So if you have like if you're using Ansible to configure the environment, you can choose that also if you choose to.
And then kind of track the Oracle data center. They're actually populating or standing up Oracle data centers in a lot of interesting places worldwide. Not your common locations are kind of branching out into smaller locations, locales.
Mm-hmm. And this is the architecture. It's a production which was me and Jeff and Checkpoint team. We published it recently, which gives you a pretty cool view, like how you can deploy the North Hub, South Hub, and different VCN via the DRG concept.
Yep.
All right. If there are no another question, we can conclude it here. It was really
Sounds
good.
Arun can go back to bed.
Yep. Thank you, everyone.
Thanks, Arun. Appreciate it. Thanks, Arjun.
Thank you.
Thanks, Jonathan. Take care.
Thanks, Jonathan. Thanks.